Hello, good morning. This is our first class, and in this class we are going to start paper 2, and paper 2 name is the optical physics, and in that optical physics we are starting unit first, that is the interference of light. So what is the interference of light? This word maybe you are hearing first time, that is the interference. What is the interference? So we already know that light is a form of wave motion. Okay, means light always is in the wave motion, and this wave motion is the transverse in nature. These waves are transverse in nature. So when a single source of light, any light, we are considering any light, when a single source of light gives out energy which distributed uniformly in the surrounding medium. So if the two, in that type, for example our home, so in that our home we are blown light, and this type of light spread all its energy around the room where it plays. So that's why a single source of light gives out energy which is distributed uniformly in the surrounding medium. So that type of light we are taking two independent sources. Okay, so these two independent sources, this is the one type of source and this is the second type of source. So this is the two types of independent source which has the same wavelength and which are capable of giving out continuous waves of the same amplitude, same wavelength and same phase difference. Means the wave has spreading light which has the same wavelength, amplitude and phase difference. Means these two sources gives out or spread light energy in the continuous manner. Okay, the continuous waves are spreading, and which waves has the same wavelength, same amplitude and same phase difference. So same phase difference means the constant phase difference. Okay, so when these two sources we are taking and the light reflected in the direction that type. So this is the direction where it spreads. Okay, so after spreading the distribution of energy of the surrounding medium is not uniformly. Why? Because there are bright and dark regions are observed, because these two sources interfere with each other. This is the interference. So this is the movement. So this is also interference. Here also interference. Here also interference, and there is an interference pattern formed. And in this interference means interfere. There is a closing of two rays. Here's the closing of two rays, and due to this there is a bright and dark regions observed. So that's why we can say that the distribution of energy in the surrounding medium is not uniform, but there are bright and dark regions are observed. So what type of dark and bright regions are observed? So here this dotted line and dashed line, we are drawing here dash line and dot line. So this dotted line is called the crest, and this dash line is called the trough. Okay, so this is the crest, trough, and crest. Then another source, this is also crest, trough, and crest. Okay, so these two patterns observed, but at the place when crest of one wave, means crest of one source, fall on the crest of other. Okay, what is the condition? When the crest of one wave fall on the crest of other wave, then or trough of one wave fall on the trough of other wave. So when what type of condition observed? Crest of one wave fall on the crest, that is when this is the crest and this is also the crest. When there is an interference of crest and crest, Okay, or trough and trough means this type of observed crest of one wave following the crest of other wave, or the trough of one wave following the trough of other wave. So at this time the amplitude increases and energy, or we can say that intensity increases. So at this place where the energy or the intensity of the wave increases, so at this place bright region are observed. So we observe bright region. Okay. So when two sources coincide with each other, so this type of condition occurs, crest fall on the crest, trough fall on the trough. So at this place amplitude increases and the energy or the intensity increases. So at this place the bright regions are observed here. And when crest of one wave fall on the trough of other wave, or trough of other wave, one wave fall on the crest of one other wave. So at this time resultant amplitude 0 and energy or intensity becomes minimum. So at this place dark region are observed. Okay, so these are the two conditions, and that type of phenomenon where the modification of distribution of energy levels means there is a, in one type there exists a bright region, means there is a modification of energy, and say at the second type energy intensity decreases, means that there is a minimum distribution of energy. Here's the maximum distribution of energy, that's why bright region is observed. Here the minimum distribution of energy, that's why dark region is observed. So this gives rise a phenomenon of interference, means that is called the interference pattern or the interference of light. Got it? So this is called the interference. So definition of interference definition: the modification according to this type, the modification in the distribution of light energy, okay, the modification of distribution of light energy, modification in the distribution of light energy due to, this is the interference of two sources. So we can say that the superposition of two or more waves. This is the one wave, second wave, third wave. So that means due to superposition of two or more waves is called interference. Okay, so this is all about the interference of light. Here these are the basic concept and definition of interference of light. So in the next topic, the next topic is the wavefront. What is the wavefront and wave normal? Wavefront, it is also known as the wave surface. Okay, wavefront or wave surface. The definition of wavefront is the wave surface or wavefront is a surface of all neighboring points wavefront or wave surface is a surface of all neighboring points. Okay, surface of all neighboring points which receive light waves, which receives light waves, which receive light waves from a source at the same instant, and are in same phase. Okay, so wavefront or wave surface is the surface of all the neighboring points where the surrounding means light blows in the surrounding medium or the energy spread in the surrounding medium. There are number of points observed, so that surface of all neighboring points which receives the light waves, means the light waves where the spreads light waves from a source at the same instant and are in the same phase. So that type of surface is known as the wavefront or wave surface. Then another definition is the wave normal. So wave normal, a perpendicular drawn. According to surface, there are three types of wavefront. There are three types of wavefront. First is the spherical wavefront. Second is the plane wavefront. And third is the cylindrical wavefront. Okay, so these are the three types of wavefront. Then the definition of wave normal. So the definition of wave normal and the description of this spherical wavefront, plane wavefront and cylindrical wavefront we are taking in the next class. Okay, thank you.